So 5th year summer exam, question 7, part A, circle question. So you're given the equation of the circle C1 and you're given a line 2xl, which is 2x minus y plus 5 equal to 0, and you're told that the circle and the line intersect at the points P and Q. The first part of the question is just asking you to write down the centre and the radius of the circle C1. So just to recap, in the x squared plus y squared plus 2gx plus 2fy plus c equal to 0. Okay, and the centre of a circle in that form is minus g minus f, and the radius is the square root of g squared plus f squared minus c. Okay, so to read off the value for g, so we're given a 2gx, so 2g is equal to the number in front of x, which is minus 2, so g is equal to minus 1, and 2f is equal to minus 4, so f is equal to minus 2, so the centre is minus g minus f, which is going to be 1, 2. Now the radius is equal to the square root of the value that we got for g, which is minus 1 squared, plus the value for f, minus 2 squared, and minus c. So we know that c is minus 20, so it's minus 20, which is plus 20. So the radius is equal to 1 plus 4 plus 20. So the radius is equal to the square root of 25, which is equal to 5. Now, B part 1 of the question, find the perpendicular distance from the centre of C1 to the line in third form, to the line L. So the line is 2x minus y plus 5 equal to 0, and the centre is 1, 2. Okay, so perpendicular distance is the absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared. Okay, so a is the number in front of x, which is 2, b is the number in front of y, which is minus 1, and c is constant, which is 5, and this is our point x1, y1. Okay, so it is 2 by 1 plus b, which is minus 1, by y1, which is 2, and then it's plus c, which is plus 5, all over the square root of 2 squared plus minus 1 squared. So that's going to be 2 minus 2 plus 5 all over the square root of 4 plus 1, which is 5. Okay, so just moving up here. It's the absolute value of 5. Minus 2 and the plus 2 cancel all over root 5. So absolute, this has to be positive. It's a distance, it's a perpendicular distance, therefore it has to be positive. So in this case we have the number 5, which is positive, so we just take it as 5 over root 5. Just to get rid of the third on the bottom, multiply top and bottom by the conjugate, which is minus root 5 over minus root 5, which is going to give us minus 5 root 5 over minus 5, which is giving us a perpendicular distance of root 5. So that is our answer. Now B part 2 leads on from this, and B part 2 says, hence or otherwise find the length PQ in third form. Now this is B part 2. So we were already told that we have a circle C1. We know the centre of this particular circle, okay, and we know that the line PQ, or the line intersects the circle at P and Q. We know the perpendicular distance from the line to the centre is, perpendicular distance is root 5, and we know the radius of our circle from part A of the question is 5. Now what we're asked to find is, we're asked to find this length here, PQ. So if we just zone in on one of our right angle triangles, we'll be able to find this length here. We could call that x or something like that, so qx. Okay, and then when we double that length, we'll have the length of the line PQ, or the chord PQ. So taking out our little right angle triangle, you can see that we'll use Pythagoras. So it's going to be 5 squared is equal to root 5 squared plus x squared. So 25 minus root 5 squared is 5, so 25 minus 5 equals x squared, so 20 is equal to x squared, x is equal to the square root of 20, and always break your surd down, so you can see that 4 5s are 20, so that's going to be 2 root 5 is equal to x, okay, or is equal to that distance there. Okay, so what we need to do is to find the length PQ, we multiply that by 2, so 2 by 2 root 5, which is 4 root 5. So the length of PQ is 4 root 5.